practice finding some common denominators now. We'll start with just some fraction examples, and then we'll move back into rational functions. So let's look at this first example. Remember, we have two ways to find a common denominator. We can either find a common denominator by doing the quick and dirty method, which is where we multiply what's on the bottom of each, or we can use the least common denominator method, where we actually do find the least common denominator and don't repeat factors. So let's look at this first example and do it the quick and dirty way first. So the quick and dirty way tells me that I want 5 times 10 as my new denominator, my common denominator. So I need to multiply my first fraction times 10 over 10 in order to do that. The second fraction I need to multiply by 5 over 5. So now I have to multiply across, so 3 times 10 is 30, 5 times 10 is 50, and then 5 times 1 is 5, 5 times 10 is 50 again. So I can add right across the top, 30 plus 5 over 50, and that's going to be 35 over 50. Now let's see what happens when we do it the least common denominator way. So I need to factor or kind of break down anything that's in my denominators. So 5 is already prime, so it doesn't have any way to break it down. However, 10 is 5 times 2. Now notice that they share a 5. Both my denominators have a 5 in them. So all I need is a 2 over here to make them match. So what I need to do is multiply my first fraction times 2 over 2. That'll give me a 2 in my denominator, and I'll have a common denominator already. So I have 2 times 3 is 6, 2 times 5 is 10, and then I have 1 over 10. I didn't have to change anything with the second fraction. Then I can add 6 plus 1 over 10, or 7 over 10. Notice that these two are not the same, but also notice that 5 goes into 35 and 50. 7 times 5 gives me 35, and 10 times 5 gives me 50. So I can simplify that fraction, and you see that I end up getting exactly the same thing. Let's look at this second example now. So let's do it the quick and dirty way. So I want to multiply my first fraction by 5 over 5, so that I get the 5 in my denominator. The second fraction I need to multiply by 6 over 6. So 5 times 1 is 5, 6 times 5 is 30. 2 times 6 is 12, 5 times 6 is again 30. So I can now add across the top, and I'm going to get 17 over 30. Now let's think about doing this the least common denominator way. I have 1 over 2 times 3, because that's how I can break down 6, plus 2 over 5. Because again, 5 doesn't really have any way to break it down. It's already prime. So notice I don't have any shared factors. This one has 2 and 3. This one has 5. So in order to make it so they have the same, I'm going to have to multiply by 2 times 3 over 2 times 3 over here. And I'm going to have to multiply by 5 over 5 for the first fraction. And when I actually do that, 2 times 3 is just 6. So I'm going to end up exactly where I was here. I'm going to end up with 5 over 30 for the first fraction. And I'm going to end up with 12 over 30 for my second fraction. Well, that's exactly what I did for my quick and dirty method. So because these denominators didn't share any numbers, the quick and dirty method and the least common denominator method are actually the same. Okay, let's look at number 3. So we want to do it the quick and dirty way first. So my denominator is going to be 6 times 10. It's going to be my common denominator. So over here I need to multiply by 10 over 10. Over here I need to multiply by 6 over 6. Well, 5 times 10 is 50, 6 times 10 is 60, 3 times 6 is 18, 10 times 6 is 60. So I can now take 50 plus 18 over 60, or that's going to give me 68 over 60, which is an improper fraction, but that's okay. We can just keep it that way. Now let's do it the common denominator, the least common denominator way. So we have 5 over 2 times 3 plus 3 over 2 times 5. So notice here that both of my denominators have a 2 in them, but one has a 3, the other has a 5. So it looks to me like if I want my common denominator, it's going to be 2 times 3 times 5. I don't need both 2's in there. So I need a 5 in my denominator over here. I need a 3 in my denominator over there. So when I multiply across, I get 25 over 5 times 2 times 3, which is 30. And then I get a 9 over 30 for my second fraction. So now I can do my addition. So 25 plus 9 over 30, well, that's going to be 34 over 30. Now notice that 2 goes into both 34 and 30. So this is actually going to simplify to 17 over 15. Because 2 times 17 gives me 34, 2 times 15 gives me 30. Now over here, in order to get the same answer we got here, I'm going to have to take a 4 out of the top and bottom. 4 times 17 gives me 68, and 4 times 15 gives me 60. Now let's go back to rational expressions. So we have the same two ways. We can do quick and dirty, or we can do least common denominator. In this case, they're going to be the same again. Just like they were here, we don't have any shared factors on the bottom. X minus 1 and x plus 4, neither of them can be simplified, so we don't see the same factor happening here and here. Because we have to treat these as whole terms. We can't take the x out or the 4 out or anything like that. So it looks to me like we're going to have to multiply by x plus 4 over x plus 4, x plus 1, or sorry, x minus 1 over x minus 1. So again, this is both the quick and dirty way and the least common denominator way. So here I get x plus 4 over the common denominator, which is both denominators multiplied. Here I'm going to get x minus 1, x minus 1, and we see that we have a common denominator, so now I can just add across the top. And it's over the common denominator. So last but not least, I can do a little bit of combining here. I have x plus x will give me 2x, and then plus 4 minus 1 will give me plus 3. So there we go. Now we have our common denominator, and we've been able to add them. Let's try this one now. So again, this one's going to have two different ways to do it. We're going to have the quick and dirty way, and we're going to have the least common denominator way. So let's do the quick and dirty way first. So I know that because I'm dealing with the quick and dirty way, I want this and this multiplied to be my new common denominator. So I think that I'm going to need to multiply by x squared minus 9 over itself times this first fraction. The second one, I'm going to need to multiply by x plus 3 over itself. So now I'm going to have a lot of simplifying to do. So I have x times x squared minus 9 over the common denominator minus 2 times x plus 3 over the common denominator. So now I can distribute, and it's all going to end up going over the common denominator. And notice I'm doing the exact same thing for subtraction that I did for addition, because I still need a common denominator either way. So I have x times x squared will give me x cubed, and then a minus 9x. Then I need to distribute this as a negative 2. So negative 2 times x gives me negative 2x. Negative 2 times 3 gives me negative 6. So let's combine like terms. I have x cubed minus 11x minus 6 will give me x squared minus 9, where x plus 3 is a common denominator. So there's my final answer for the quick and dirty way. This will likely be able to be simplified, but we can't see it right here, not yet at least. So let's do the least common denominator way now. So x plus 3 can't be factored, that's all set, but x squared minus 9 is the difference of two squares. So I have x plus 3 times x minus 3. So I have a matching factor of x plus 3 in both denominators. So all I need to do is I need to get an x minus 3 into this denominator. So I need to multiply by x minus 3 over itself. And then that second fraction is all set. It already has both pieces of the denominator. If I had a factor over here that I didn't have over here, I'd do the same thing. I'd multiply by that factor over itself. So I have x times x minus 3 over the common denominator minus the original second fraction. So I'll get x times x minus 3 times x minus 2. And I could continue to write this out the factored way, but I know what this multiplies out to. It's fairly simple. Might as well write it out that way. Save myself a little bit of writing. So we can see that they don't look the same the answers don't look the same when we do it the least common denominator way and the quick and dirty way. It looks to me like there should be some factor of x plus 3 that'll cancel out, and we could simplify the first one. And we should get this. Okay, one last example. Let's take x squared over x minus 2 plus x plus 1 over x squared minus 3x plus 2. So again, we'll go through and do this the quick and dirty way, and then we'll do it the least common denominator way. The quick and dirty way is going to get a little bit messy, especially because we have a 3-term denominator here. It's going to just get a little bit long to multiply out, but we can do it. So I need to multiply both denominators to get my common denominator. So the first fraction I need to multiply by my quadratic denominator. The second fraction I'm going to need to multiply by the x minus 2. There we go. So, I have x squared times x squared minus 3x plus 2 all over the common denominator, which is both denominators multiplied, plus x plus 1 times x minus 2 all over the common denominator. Okay, so the top, let's go through and multiply. So x to the 4th from x squared times x squared minus 3x cubed plus 2x squared. Plus, and then I need to distribute this first factor through the second one. and that whole thing goes over the common denominator. Okay, last but not least, we need to multiply these out and then combine like terms. So I have a plus x squared and a plus x from this first distribution. For my second one, I get a minus 2x minus 2. Okay, now all I need to do is combine some like terms. So I have x to the fourth minus 3x cubed plus 3x squared minus x minus 2. That all goes over the common denominator. So as you can see, that was a lot of writing and a lot of multiplying. Let's go through and do it the least common denominator way now. So my first denominator, x minus 2, I can't factor. It's just going to stay as is. My second one, I can factor. I want two things that or two numbers that multiply to 2 and add to negative 3. So I think I'm going to need negative 2 and negative 1 for that. But now we can notice that we have an x minus 2 in both of our denominators, so all I need is an x minus 1 over here. So I can multiply by x minus 1 over x minus 1, and then I can leave my whole second fraction alone, which saves us a lot of the steps that we had to do over here. So I get x squared times x minus 1 over the common denominator. And notice I have them written in two opposite ways. That's fine, because multiplication, again, we can flip it around. It's commutative. So now I take x squared, x squared times x will give me x cubed minus x squared plus x plus 1 all over my common denominator, which I know was already the denominator over here. So I can either write it like that, or I can leave it in the factored form. So notice that we have some simplification that we have to do here to get back to here. And notice how much more work this was. In rational functions, often this will happen. You'll end up having to do a lot more multiplication than if you do it this way, but both are fine.